How many people during the last break were working on building and deploying an ion? Okay, pretty large fraction. How many people got as far as invoking an ion with a lambda? Smaller number. So I'm happy to stick around at the end today for people who are wanting to work on that. Did anybody go all the way to API Gateway? All right, intrepid. So a couple of things about the API Gateway. Obviously, once you get there, you're at the limit of the automation that Datomic Cloud is providing right now. So the API Gateway was go and use the UI or use the command line tools to make an API Gateway. Because the API Gateway is outside of our automation, that's not something that we will tear down for you. So if you're wanting to clean this up at the end of the day, those of you who got to the API Gateway, make sure that you remove that piece explicitly. Just tear down things in the opposite order that you made them. So remove that one first. In this case, you're tearing down everything, maybe it doesn't matter, but make sure you tear that thing down first. And remind me, at the very end today, I'll walk you through the cleanup instructions and issue you your AWS cashback that I promised. So don't let me forget to do that, because I don't know what I'm going to do with a wad of $2 bills otherwise. So, any questions about ions? So the major idea there is deploy your own application to the same kinds of clusters where the database runs, have in-memory access to your database, and have access to all of the codified AWS best practices that are already present in your data tier when you're using Datomic Cloud, and not have to do any of those things. So I'd like to wrap up by talking about what it's like to operate a system running Datomic Cloud and the kinds of choices and opportunities that you have when you're doing that. So I'll also go back and answer a question now that was asked in Slack earlier today, which is, what's the timeline for having something like this for Azure, or having something like this for Google Cloud or some other cloud? So our approach, I like to think of Datomic Cloud as a hosted database. It's hosted on Amazon Web Services in the same way that Clojure is hosted on the JVM and then re-implemented to be rehosted as ClojureScript on JavaScript and so forth. And the idea there is an important one, and it's a trade-off that's chosen, right? When Rich was originally designing Clojure, he targeted both the JVM and .NET for a while. And he eventually decided that he could get 5 times further if he focused his efforts on a single platform instead of trying to meet a common denominator between different platforms. Now, since then, David Miller has got Clojure running on the CLR, and David Nolan and others have Clojure running on JavaScript, and there are other ports of Clojure. But the point is that if you're actually trying to get things done and not hedge your bets, you can get a lot more done by targeting a platform. And this is true. This has been true for my whole career. At the beginning of my career, this was often about, are you going to target Windows or DOS, or are you going to target Windows, or a little bit later, the Mac, those kinds of things. And there were people who made the argument for, I want to target an indirection layer so that I can get a double return on investment for my work. Right? I'll write something that goes to an intermediate library that lets me target those things. And there were people who were saying, I want to get maximum power out of the individual platforms, and if I want to target more than one platform, I know that I'm going to have to do a bunch of work again. Datomic Cloud is definitely in that we want to leverage the platform camp. And so Datomic Cloud is built directly against the most powerful AWS capabilities we can find wherever we can find them, which means that when we want to make Datomic run on another cloud, we have a substantial chunk of work ahead of us. So I would say if you're holding your breath for that, you should bring an oxygen tank. Because, not saying never, but our emphasis right now is making the best possible leverage for building AWS applications. Having done that, there are some important values that come into play. If you're embracing AWS, right, you're the target audience. If you've chosen to embrace AWS for your applications, then your programs are going to be the same at all scales. So one of the other things that's been a truism throughout my career is I've watched people build something in the small and have it succeed, and have to rebuild it again on a radically different architecture when it becomes large. Now, the objective here is not to have to do that, and we're going to walk through the steps you would go through as you grow an application from a happy idea in your garage or your basement to a giant world-spanning behemoth, and how you would grow with Datomic as you do those things. Datomic lets you scale at kind of 3 different levels. At the storage level, you're built on top of scalable AWS resources to begin with, right? S3 and EFS and DynamoDB all scale fairly arbitrarily. So you're going to get that in your use of storage. At the transaction level, Datomic is not a right-scale system. So you can scale your operation of Datomic by creating multiple systems or by having more machines in your primary group, but that's an explicit operation, and that's not primarily what Datomic is about, right? We're not aspiring to be a right-scale system. There are other trade-offs associated with that. On the other hand, scaling applications and query are very much what Datomic is about, and in particular, you can elastically auto-scale your entire application. Another challenge in building these systems in AWS is if you have 3 different layers, then how do you scale it? And what happens when this layer, a lot of times you'll have the situation where this layer scales beautifully, and then it turns around and crushes the next layer, and so you're not able to get the benefit from that scaling anyway. And so having accepted that we're not going to be a right-scale system, we can scale beautifully everywhere else. So if that's a trade-off that matches the thing you're building, we think this is pretty good. So life starts small. You're building an application, and you start a Datomic solo system, and you build a little web app. I'm going to call your app Web. It's not very exciting. You could have it be called something else. You're going to have a Git repo called Web, and you have an application which is created for you by Datomic Cloud, and then you're going to say, I commit to my repo, I issue a push command to push that Ion code to my Datomic Cloud application, and then I issue a deploy command to deploy my entire application to that tiny little solo topology instance. And people are doing this. I've been amazed. I mean, Datomic Cloud has been out since June, July, and there are a bunch of people who are in production already building departmental scale things that respond to AWS events on Solo. And they are doing this entirely, I think, to get the convenience of the programming model. They're familiar with Clojure. And so they're like, I want to build something that can respond to Lambda events, but I don't really want to work with the Lambda infrastructure. I want to write Clojure functions. So they may not even be using Datomic as a database very much. They're just saying, I want to do something when something gets dropped in an S3 bucket. Or I want to do something when I have a scaling event. I want to have some reaction to AWS events. Great. An obvious next step from that is to say, I want to support different development stages. So I have developers that are working against a developer group, but I also want to have a CI system that runs my tests. I want to have a staging system that stakeholders can go and look at, and then I want to go to production. You'll notice in this picture that everyone's using the same repository, so staging stages the same app we're going to go to production with. It wouldn't make sense to stage a different app, but that we're running different versions of the code. So the primary group's running what I'm going to call revision 53. We don't really have revisions in Git that way. They'll be SHAs, but it's easier to think about it here by giving them numbers. So we're going to be running an old version that's relatively stable. CI is running the hottest thing that we just pushed. So commit 55 is the most recent thing we pushed into CI. So CI is churning through that. Staging is running something in between those things, right? It hasn't gotten through CI yet, so we can't stage it. But it's not something we like well enough to put to production yet, so it's running version 54. And the developer is just sitting there issuing ad hoc queries and transactions to the dev query group. Now, all of this is running against a single production topology system. That production topology system can have multiple databases in it, as it obviously does. It has the primary group that's serving production, which are on large instances. Notice that in this picture, the only one of the 4 groups that has more than one instance in it is the primary group. So that means we have failure modes in CI and staging. If an instance died, we'd have an outage that was, however long it took to detect that and bring it back up. So probably a minute and a half, something like that. In production, we don't have that problem, right? If an instance died, traffic would be redirected to the other instance, and we would be happily moving along. Also notice that we've chosen to make instances of different sizes. T2 mediums are far less capacious than I3 larges, and therefore they don't cost as much. And we're operating on the presumption now that our CI and staging use is not nearly as intensive as our production use. Is that always true? No. I mean, it could be the opposite. It could be that you want to run a load test, in which case it may be that wherever you're running that load test is going to be far more utilized even than production. You're going to push it and see where the limits are. One of the things that you don't see in this picture necessarily is how long are these instances kept around. Right, the way the picture is drawn, I've shaded in staging and CI and primary as around all the time, and I've put a dashed line around the dev group to indicate that the dev group is only on when the dev is using it. So you can use auto-scaling rules to say, you know what, we're going to leave the system on for 10 hours a day. From an hour before start of business to an hour after start of business, we cut our cost in half, more than in half for that group because we're not running 24/7, because we don't need it because the devs aren't working then. If a dev is working, then what do? They go into their console and they override the auto-scaling group and turn the thing back on. I actually did that today. The system that I was deving against was down because I hadn't been using it. So I just turned it off in auto-scaling because I wasn't using it. When I came in here this morning, I turned it back on in auto-scaling and brought it back up. So I didn't need it until then. This is showing an example, but the choice is up to you. You could choose to run, maybe you really do a ton of work in CI. Maybe you want multiple machines there because you're committing all the time and you want to be able to keep up with those commits. I don't know, right? The point is, the really important point is, these decisions are independent. And these decisions have to do with availability, so whether or not you have more than one machine. They have to do with scale, right? Again, with whether or not you have machines that you could increase the number of to deal with scale, and with whether you want to operate 24/7 or not. You can make independent decisions for your different development stages. And of course, you could make decisions I haven't shown here at all. You could go completely independent and say, you know what, I'm going to use a different solo system for every single one of these phases, right? So they can't even see each other's data and so forth. And there could be reasons to do that as well. So this is showing an example of what you could do, but you should take this example as inspiring as opposed to prohibitive, right? So if you want to do something different, it's the axes that you can change things on that I'm trying to point out. Now, your usage of the application grows. And in particular, you have a lot of traffic coming into the web app. So you stop serving the web from your primary group, right? It doesn't serve requests at all anymore. Instead, you create a web app query group and install the application there. So we're no longer installing the application onto the primary group at all, because it doesn't serve requests coming in from the outside world. And we set up that group to auto-scale from 2 up to 6 based on CPU utilization 75%, or whatever you figure out, is how you want to set the scaling. Everything else is running as it has before. And now when you have surges in web traffic, you can cope with them. Now, not shown here because it clutters up the pictures. Where do all the transactions execute? Always in the primary group. So writes always happen in the primary group. So planning for write expansion is more of a let's have a meeting kind of thing. Right? Let's sit down with the team and say, you know what, we're going to serve 25 different databases out of here. Let's make the primary group have 5 nodes on it. But that's more of a fixed size thing. It sort of undermines Datomic's use of SSDs for caching if you change the size of that group casually. So, and you'll see this in the documentation, do not auto-scale the primary group. Right? When you want to auto-scale something elastically, you want to auto-scale a group that's not the primary group. Okay. And how much did you change your application from your solo topology to take advantage of this? Zip. Right? The one thing you change in your application is what endpoint you connect to. So every one of these groups has a different endpoint. So you have a configuration of, I'm connecting to the endpoint that is the CI group, or I'm connecting to the endpoint that is the primary group. But other than that, you're changing nothing. And I should show you one thing you may not have seen before. It's a little bit less common. What's it called? System Manager. So AWS has a thing called the parameter store. And the parameter store has in it named parameters. You guys cannot possibly see that. So this is a parameter called Datomic shared staging stu8 db name. The thing about this is you have parameters that your application might need to run, like the name of the database to connect to, or the name of the Slack room that it's posting to, or the kinds of events that it wants to handle. Those kinds of things you can specify in AWS Parameter Store, and Ions provides an idiomatic API for pulling this stuff out. And the hierarchical thing allows you to secure it so that you can say, hey, we don't trust Stu with anything but dev, so Stu is not allowed to configure or manipulate the configuration of anything that has the staging prefix or anything that has the production prefix, for that matter. And so you can do prefix-based security around these parameters, and the parameter lifecycle is completely decoupled from anything about Datomic or your application. Right? So this is managed entirely separately by potentially entirely separate people, which is exactly what you want when you get hardcore. Right? You're going to have ops people who are compliance authorized to come in and do whatever. They can come in here and set up parameters, and they can say, you can have access to this, and you can have access to something else. And that life cycle is completely decoupled from anything about running your system, and then you can programmatically get access to that with an Ion API that lets you get those parameters. And you're going to care about parameters the minute that you're deploying the same application to more than one group. So the minute you move from this picture to this picture, you're going to say, you know what? CI needs to know the name of the database it's talking to, which had better not be prod. And staging needs to know the name of the database that it's talking to, which had better not be prod, and so on and so forth. Now, transaction functions are special. Transaction functions, and we only talked about these briefly, run inside of a transaction and allow you to make updates that are based on the current value of the database. Transactions only run inside of the primary group. So when your operation reaches a point where you are caring about transaction functions, then you want to create a separate application, separate GitHub repo, right? That is my transaction function application, and you install that application to the primary group. Notice that the revision number there is 5 instead of in the 50s. Well, it's a different repository, so it's going to have a different revision numbers. But that's also meant to suggest that this is probably something you touch far less often, right? Extremely rarely. This is right the crown jewels of the applications code you let run inside of the write pipeline is something that you want to be very considered about. So you run those in a separate application. Now, what happens if the transaction functions and the web application need to use some of the same code? That's a beautiful thing, right? Because we're using tools.deps to manage this. So you make a GitHub repo that's called shared across my system, and then each of these declares that as a dependency. You don't even ever have to make a Maven artifact, right? You just make that shared code be in its own Git repo and party on. And then eventually, your system grows large enough that people want to run more than one application against the same data. And the canonic motivating example that we always use is you built a web application, and now you're all grown up, it's 3 years later, and you've got some experts in who want to analyze the data about your system. They want to do some analytics. And first off, it's a different application, right? They're not transacting at all. They're not asking the same kinds of queries. They're rolling up things. Their queries are really large, because most of the queries in your web application are look up the information about this one user or about this one entity and do something. And the analytics thing is totally the opposite. They're like, let's spin through the whole database and check for this. These are the people that might not even use the query API. They might call the datums API and MapReduce over it or something like that. So that team does not want to be running in the same group as the other team. With a lot of database technology, this is the point where you'd say, okay, you know what? We need a different database. We need to back up our database and restore it into a database that has a different shape. So we have to move from a row store to some sort of dedicated, analytics type environment. With Datomic, instead of doing that, you just say, you know what? Let's fire up a new group. That new group is a different application. And when you created your system, I don't know if you remember this. This is back at the beginning of the day or even yesterday. You said, create a system name followed by an application name. And it said, warning, these names can't be changed later. And then it said, the heck with it, just leave it blank for now. Right? This is where you come back and say, I want to have this group, I'll give it a different application name because we're going to deploy different code to it. So when you create the group, you explicitly go in there and set an application name so you can say, I'm going to deploy that application to it. Now, again, this is hardly exhaustive. In some compliance settings, it would be completely unacceptable to have prod have any of this other stuff in it, except maybe analytics, if it was read-only. So if you need something like that, you can obviously run more than one system. Right? And by the way, when you run more than one system, applications can target more than one system. So that's another case where when you're setting up the system, the first time you set up your system, it's like my little toy system, and then you give it an application name called my beautiful app. When you set up later, you said, you know what, we're going to move production off to a different system. You create a new system called production, but you put in the same app name that you put in for that first system. Then you can deploy things into the first system, make sure they're working, and then turn around and deploy them into the other system. So you have that ability. You don't have to worry about the cardinality of that relationship. So I think for a certain class of application, this is very powerful. And for other applications, it's not a fit at all. And so for the last lab, which is going to be homework, so I expect everybody to send me an email, I want you to take the data set that you designed a schema for this morning, and I want you to create a comparison matrix where you look at, is Datomic Cloud actually a good fit for what I'm trying to do here? And the objective here is not to make Datomic feel better. Datomic doesn't get hurt feelings because it's not a human, it's just an abstract, it's just software. The objective is to really do, which characteristics of Datomic are going to help me here, which ones are going to be in my way. And it's probably going to be the case that it's not like a perfect match and it's not like a perfect non-match. And compare it to some other choice. And you may find that we've covered a lot of topics today and you can't remember all the characteristics that you might want to consider. So I have made a handy list of characteristics that you might think about, which is mind-melting, right? Because there's 100 different things. Okay, maybe that's a little bit too much. So let's back up and instead, let's talk a little bit about where Datomic is clearly going to be a poor fit. I think I've been pretty clear from the beginning of the day, Datomic is not for right-scale systems. If you are taking terabytes of logs and spinning through them and trying to understand the underlying emergent patterns in your system, don't use Datomic, right? Datomic is not for media storage, right? You can't put movies in Datomic, you can't put videos in Datomic, and it's not a good fit for documents. Don't put Word documents or, blobs of text. It's not a good fit for. It's also not a good fit for things that you don't care about the history of, right? So for example, a hit counter on a web page, you don't care about the history of it because before its value was 999, what was it? By definition, 998, right? It's more of a thing that you care about in the aggregate. You don't want to record the history of your hit counter. So these are things for which Datomic is not a good fit. Now, having said that, most of the big data right scale problems have to be solved with hybrid approaches anyway. And so one of the things that we have seen Datomic be a good fit for is people use Datomic as the metadata store for a big data system. So they have a system that's processing huge amounts of data, but they also have human scale data about that data that people have to look at and consume. And so they use Datomic for that piece, and they use Cassandra or S3 or whatever. Looking at a system right now that is being used in medical research where the big, actual source data from the experiments is in S3, but the roll-up data that people analyze is stored in Datomic, that kind of thing. Datomic is a good fit for information of record. If you have a data of record system where data is put in by humans, so business records, transactions, financial transactions, scientific records, inventory, configuration. This is a particularly interesting one. Right? Where does configuration data live? I mean, you care when your system falls apart and you change the configuration, you care what the history of your configuration was. It's a great example of a place where you would want structured history. Departmental databases, web applications, in many cases, cloud applications. When you want development and ops flexibility, the fact that Datomic is not a slot-oriented database, right, is a beautiful thing at an information level. Right? Information comes to you in all shapes and sizes, and Datomic says, you know what? I don't know what you're going to know about this thing. You can come up with new things that you're going to know about it later. Totally happy to that. Likewise, operational flexibility. You can start small with Solo and then stay small forever, or if things radically change, you can radically change without changing your application. And obviously, Datomic is a very good fit for history because there's some magic sauce, which is... And it's really good for read scale because there's some magic sauce, which is immutability, right? That's where the magic comes from in a lot of these things. So what we're going to do now, let me do a chime check, so we're right at 5 o'clock, is I'm going to take questions for 15 to 20 minutes. And at the end of that time, if you want to, you don't have to, but if you want to write up your assessment for where you think Datomic is a good fit for the data that you modeled and where you think it's a bad fit, and email it to me and get feedback and my take. It's a great back and forth to sort of really try to pit this against something you're trying to do. I can't promise that I'll respond to all those emails tonight because I will fall asleep eventually, but I'm happy to respond to those emails and continue the conversation out of band. So what I'm going to do now is I'll take questions for a few minutes. Let me talk a little bit about cleaning up your system. So there's 2 levels of that. One is you can leave it on. It'll cost you about $1 a day. You can play with Datomic. I would be thrilled if you did that. The second thing is you can delete the CloudFormation template. So you can go into CloudFormation and pick your stack and pick Actions Delete Stack. If you pick Actions Delete Stack, what's going to happen is that all of the active computational resources will be destroyed, which is all ephemeral stuff anyway, and the load balancers, all those kinds of things. Primarily a compute instance, because most of that other stuff doesn't exist in Solo anyway. The durable resources will not be destroyed. So S3, Dynamo, and EFS will stick around, which means that if you ever restart your Datomic system later by bringing up the stack again, you'd have the data that you put in today and you could get back to it. That data is small enough that it will stay in the free tier of your AWS usage. So AWS has a free tier at the bottom that's like use a little tiny bit of Dynamo, use a little tiny bit of this and that, you can allow to do that. So that will cost next to nothing to leave up and could let you come back to it later. So I recommend that you do that, and you can always check your AWS bill and make sure I'm telling you the truth. But if you want to destroy that stuff, we do not provide automation for it because it's data destroying and we want that to be hard and painful. So you have to go and manually delete the bucket and things like that, and there are instructions on the Datomic site for irrevocably destroying data, which is not a thing we like to do. But if you go to the operations page and go to deleting, this first step is deleting CloudFormation stacks. That will get rid of the lion's share of the $1 a day expense. And then there's deleting durable storage that's marked with this will permanently delete all databases and logs. And this is a set of manual steps where you go through and delete the underlying durable resources. So you don't need to do that from a financial perspective. If you leave that stuff up, you probably won't ever even notice it on your AWS bill. Like it'll be sub-penny, kind of level. But you can enumerate that stuff. And obviously you can come back and do that at any time if you want to. So with that said, my name is Stuart Halloway. It's been a real pleasure to have such a large group of people here learning about Datomic Cloud today. Thanks for hanging with me today. You can reach me, Stuart Halloway, on Twitter, or you can mail me directly, stu@cognitech.com. If you are contacting me about this class, please say, hey, I was in the class, because I'm decent at remembering names, but I probably won't remember every name. So let me know, where the contact is coming from, and I'm happy to talk to you. And with that, I'll open it up for questions. And by the way, it's after 5, so this can be questions about anything. If you want to ask me general advice about how to play basketball or improve your life or whatever, I'm happy to take anything at this point. Yes?
Coming from a traditional database background, one of the things that I'm used to being able to do is export the schema of the database. So is there, are there patterns out there for querying because it's all data in Datomic.
Right.
Are there scripts out there that say, hey, this is the query you run to get all of the things that are in the DB, blah, 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 namespaces type things?
Yes. So there are sample queries in the Day of Datomic site that show how to query the schema. If you look at the schema documentation page, it will say that several attributes are required for any schema element. So if you query for any one of those attributes, you're guaranteed to get everything about your schema and nothing else. So DB cardinality can only be set on a schema element. So if you query for everything that has a DB cardinality, you get your whole schema. If you query for anything that has DB value type, which specifies the type, then you're going to get everything that's in your schema. So you can walk up to a database and query all of those things and dump them out as JSON or whatever you want to do. We do not currently have command line tools like you're traditionally used to with databases for doing those kinds of jobs, and that will probably come at some point. But today, it's programmatic. Yes?
What's the best way to stop the system, say I want to come back to it in 5 days from Strange Loops over and do some more development, but I don't want to cost myself $5 in the meantime?
Right, how do I stop my system for now? Go into the auto scaling group that controls your instances and set the desired number of instances down to 0. And then it will turn off the compute, and then everything else will just sit there. Let me actually bring this up. I never can remember how to do this. So let me bring this up and make sure that I'm telling the truth. So I go into under EC2, and go to auto scaling groups and find the group, and then in here there's a scaling policy. Somewhere in here there is a, it doesn't have a policy. You can probably do this by a policy as well, where you say, right, so I'll post a link or instructions in the chat later today, but basically it's on either auto scaling group or maybe it's on launch configuration. It's on one of these things that you can specify, I only want no instances. The other thing you can do is just delete the CloudFormation stack and remake the CloudFormation stack. That's a little bit heavier weight, but that also works. So either one is fine. You can either turn the instance count down to 0, or you can delete the CloudFormation stack. Now, if you put a bunch of data, which you wouldn't have done today because you couldn't have put in data quickly enough with Solo, but I mean like a really large amount of data, then you would eventually get to a point where the data at rest actually costs you a noticeable amount of money. Right, this is the data sitting in S3, but that would not have happened today. That would all stay in your free tier. Yes?
Overall, how has like Datomic's evolution gone from Clojure's evolution? Has Datomic stayed, like the mindset that you do when you're designing things with Datomic stayed relatively stable? Or has there been have they moved?
And I couldn't hear the first part of your question. You said compare to Clojure?
Yeah, compared to the Clojure language, like have you really seen much like as you get new things in Clojure, how much do they really affect your Datomic, like the Datomic like API, the way you use Datomic, or the way it's even been developed?
So let me just say categorically, because this is not always clear to people on the Clojure side of things, that Rich is the benevolent dictator for life of Clojure, and every commit that goes into Clojure is designed by Rich, even when it has somebody else's name on it. But lots of other people help. Likewise, everything that goes into Datomic is designed by Rich. So at one level, there's one person who's been thinking about this stuff for a long time, who is the current arbiter of design decisions. So you would expect to see a lot of similarity in the evolution of Clojure and the evolution of Datomic. One place that this stands out is that we are very careful about compatibility. And so, Clojure just never has breaking change. Now, Datomic on-prem has had a tiny bit more breaking change than Clojure has, and the reason is that we depend on a lot of Java libraries, and those Java libraries have forced us to upgrade for security issues across breaking changes. So we've been compelled a couple of times with Datomic on-prem to make changes that affect wire compatibility between peers and transactors. So that's a bummer. It is our hope that we are insulated from that to a great degree in Datomic Cloud, because AWS is also really careful about not making breaking change. And we are also dependent on far fewer libraries because we're not dependent, we use very little in the Java ecosystem now. We really use AWS's libraries, and those have been more stable than the Java libraries we rely on in on-prem. So stability is an important characteristic across both Clojure and Datomic. I'm not sure what other characteristics. So I think the other thing that's worth saying is that the design process is often decoupled by years from the implementation process. So we have things that we did design work on before we started implementing Datomic that have still never been implemented. And so there's the possibility for seeing what looks like kind of synergy between different things that emerges from just being on a long timeline, right? Where it's like, of course this fits together with that because all these things were considered 10 years ago and trade-offs were considered and hopefully in a good way at that time. Other questions? Yes?
What's the biggest thing that's been deployed to production on Datomic?
What is the biggest thing that's been deployed to production on Datomic? So Datomic on-prem or Datomic cloud?
Either one.
Either one. And by big, do you mean the largest database or largest number of users or?
Like throughput.
So I don't think we know from our users. So we sort of, and I said this at a Day of Datomic a few years ago at ClojureConj, and have regretted it ever since. So hey, let's just jump in and say it again. 10 billion datums is a number at which, if you anticipate reaching that size in your system, you should contact us and discuss how to plan ahead so that you can scale. Is not a hard limit. And so there are certainly multiple users who are in production larger than that. All of them have had challenges that they had to overcome to varying degrees. So 10 billion is not where you catch on fire and it stops working. 10 billion is where you catch on fire and you have to put the fire out, potentially. So no matter what I say there, people are going to run off and just, So the last time I said this, we get, support requests saying, oh, we're preparing to move off Datomic because we're, within a 5 million datums of the 10 billion datum limit where it explodes. And it's like, well, if it's working fine now, it's probably going to be working fine, a few more datums. And the whole system is dynamic. There's no, hard limits like that encoded in the system anywhere. It's more a matter of, where are you from a sweet spot performance-wise. I think the sweet spot for Datomic is smaller data volumes than that need a ton of flexibility and have tons of read. And there are a huge number of applications, that fit that. And so, I think that 10 years from now, when I look back on what I think of as the biggest successes, I'm more likely to point to something that has a smaller data volume, but a higher number of users and a higher number of reads and people that care about that. That being said, one of the largest publicly talk-aboutable ones is Nubank, which is running, banking infrastructure on top of Datomic. And Joe, if you're in here, maybe you could drop links to. They've done a ton of presentations and videos about their own use, and in some of them they've talked about their scale. And so I don't want to speak for them about their scale, but there's a ton of public stuff out there where they've talked about their scale. So they're a good example of operating a large Datomic system on every axis I can think of. Large number of datums, large number of transactors, large number of peers, large code base. They're large in every sense of the word. And so looking at what they've done and what they're willing to say publicly about it would be a good place, probably the best place to get an indicator on that. There's a question in the back, maybe? Yes?
I have two questions. So the first one is a bit general. So what I love from the presentation is you took the programming model and then put it into cloud. Like took the IONS model and then make it transparent that you could easily publish.
I'm really having trouble hearing you.
So one lesson I learned is you took a programming model like IONS and then hide the complexity of cloud from that model. So if somebody wants to do something like that, let's say in a private cloud, are there general lessons that you can share that, what are you looking at and
Oh, that's a good question. So let me say that back so the rest of the room can hear it. So with IONS, you provided a programming model and you have abstracted away some of the complexity of operating on AWS, are there lessons learned about that somebody could apply on a private cloud when trying to do their own thing with Datomic, or maybe not with Datomic, right? On how to provide that power. So what's the secret sauce that makes everything better? Immutability. If you're not building on immutable stuff, figure out how to do that right now. That would be the first thing that I would say. The second thing I would say is take a look at, if you haven't already, at Rich Hickey's talks on hammock-driven development and simple made easy. These are really the two talks. Maybe somebody could drop links to these in the room. These are really the two talks that lay out the design philosophy that Rich uses when he's designing systems, and you can really see those throughout Datomic. All right, I'm going to shut down open questions so I can move to the back of the room and hand out cash prizes. But I'm willing to stick around and take questions one-on-one as long as anybody else wants to do it. So thanks again very much. I hope you've enjoyed the day, and I hope you enjoy the rest of Strange Loop.